The video shared on X by Tesla Semi director Dan Priestley has sent shockwaves through the industry, proving that this 1,072 horsepower machine can reduce the risk of jackknifing on ice by 70%, thanks to a VDC system that responds 40 times faster than a diesel truck. By controlling independent torque at microsecond speeds, Tesla is showcasing an absolute mechatronic advantage that the traditional transportation industry has never witnessed before. But will this digital leap forward truly save thousands of drivers' lives in the real world, or is it all just a flawless theoretical performance staged by Tesla? In the demonstration, a fully loaded Tesla Semi intentionally drives across an icy road where heavy-duty trucks are particularly vulnerable to skidding, trailer swing, and jackknifing due to the extremely low coefficient of friction between the tires and the road surface. Instead of sliding out of its lane after briefly losing traction, the Semi quickly regains stability and continues along its intended path with minimal steering correction. Dan Priestley later clarified that the trailer was not empty, but loaded with concrete blocks positioned over the kingpin and solid steel bars distributed throughout the trailer, creating a realistic freight load rather than an idealized test configuration. This detail is crucial because a loaded trailer dramatically increases the vehicle's total mass and inertia, making it much more difficult to recover once instability begins. Since the Tesla Semi is designed to operate at a gross combination weight rating of up to 82,000 pounds, demonstrating stable control under load provides a far more meaningful indication of real-world performance than tests conducted with an empty trailer. The performance shown in the video is made possible by Tesla's in-house vehicle dynamics control system, which represents a fundamentally different approach from conventional heavy-duty diesel trucks. The system continuously processes data from high-resolution sensors monitoring wheel speed, steering angle, yaw rate, lateral acceleration, and tire grip hundreds of times every second. Using this information, Tesla's control software calculates the precise amount of torque required at each drive axle before instability develops. In contrast, most diesel Class 8 trucks rely primarily on electronic stability control and anti-lock braking systems, which intervene only after wheel slip has already been detected by selectively applying the brakes. Braking alone removes energy from the vehicle but cannot actively redistribute propulsion. Tesla's VDC, however, can instantly increase, reduce, or balance motor torque, preventing a minor loss of traction from escalating into a full jackknife or spin. This capability is possible because of Tesla's tri-motor electric drivetrain, which produces approximately 800 kilowatts while delivering immediate torque without the delays associated with turbochargers, multi-speed transmissions, or hydraulic brake actuators. The two rear-drive motors can be controlled independently, allowing the system to perform highly precise torque vectoring under constantly changing road conditions. Instead of waiting for mechanical systems to respond, the electric motors adjust output almost instantaneously through electronic commands, enabling hundreds of torque corrections every second. This rapid response is particularly valuable on snow and ice, where available tire grip can change dramatically within fractions of a second. Even a small improvement in response time can determine whether a truck remains stable or begins an uncontrollable slide. If Tesla Semi's technology performed as intended, what caused its first fatal crash? The first known fatal crash involving a Tesla Semi has drawn significant attention because it raises questions not about the truck's electric powertrain or stability system, but about the effectiveness of its active safety technologies when a driver becomes incapacitated. According to preliminary statements from the Lyon County Sheriff's Office, the driver of the Class 8 electric truck may have fallen asleep before striking two passenger vehicles that were stopped at a traffic light on U.S. Highway 50 near Dayton, Nevada. The collision killed Sergio Bu and Jennifer Villanueva at the scene, while a third person was airlifted to a local hospital with life-threatening injuries. The Nevada State Police Highway Patrol is continuing its investigation, meaning the exact sequence of events has not yet been officially determined. However, the preliminary findings already suggest that the accident was caused by a possible lapse in driver attention rather than a failure of the truck to maintain stability on the road. This distinction is important because Tesla Semi does not currently offer full self-driving capability for commercial customers. Although Tesla describes both production versions of the Semi as being designed for autonomy, autonomous driving remains under development and has not been released for customer fleets. Just 3 days before the Nevada accident, a Tesla Semi carrying experimental full self-driving hardware was spotted testing near Tesla's engineering facilities in California without a trailer, indicating that autonomous technology is still being validated internally. In the Nevada crash, however, the truck was operating under full manual control, meaning responsibility for driving remained entirely with the driver. As a result, the incident should not be viewed as a failure of autonomous driving software, but rather as an accident that highlights the continuing importance of active safety systems when human error occurs. The reported cause of the crash immediately shifts attention to one of the most important unanswered questions. Why didn't the truck automatically slow down or stop before striking vehicles that were already stationary at a signalized intersection? Automatic emergency braking is specifically designed for situations like this. The system continuously monitors the road ahead and automatically applies the brakes if it determines that a collision is imminent and the driver fails to react. Because the two passenger vehicles were reportedly stopped at a red light, the accident represents exactly the type of scenario that modern collision mitigation systems are intended to address. Whether Tesla Semi's AEB system attempted to intervene before the collision remains unknown, as neither Tesla nor investigators have released any information regarding the truck's pre-crash behavior. Most modern Class 8 trucks are already equipped with advanced collision mitigation systems supplied by companies such as Bendix and Detroit Assurance. These systems can detect slower-moving or stationary vehicles, warn the driver of an impending collision, and automatically apply emergency braking if necessary. Their growing adoption has prompted U.S. regulators to propose requiring automatic emergency braking on all newly manufactured heavy-duty trucks, with performance standards intended to allow trucks to stop automatically for vehicles ahead at speeds of up to 62 miles per hour. The proposal reflects increasing recognition that fatigue and distraction remain among the leading causes of serious trucking accidents, regardless of vehicle type or powertrain. Tesla previously stated that the Semi comes standard with enhanced autopilot hardware and uses the same camera suite found in its passenger vehicles. The company's Model 3 and Model Y already include automatic emergency braking as a standard feature capable of detecting obstacles across a broad operating speed range. Tesla has also stated that the Semi's independently controlled motors are designed to help prevent jackknifing. However, the company has never published Semi-specific specifications describing how its forward collision warning or emergency braking systems perform under commercial operating conditions. Tesla has not disclosed detection distances, braking thresholds, or whether the Semi's collision mitigation system functions identically to that used in its passenger vehicles. Consequently, it remains unclear whether the truck detected the stopped vehicles, whether emergency braking was activated before impact, or whether other factors affected the system's response. Until investigators complete their analysis or Tesla releases additional information, these questions cannot be answered with certainty. The accident has also renewed attention on driver fatigue detection, an area that is becoming increasingly important throughout the commercial trucking industry. Although fatigue monitoring technology is now widely available, it remains optional rather than federally required. Many fleet operators purchase systems from companies including Netrodyne, Lix, Samsara, and Seeing Machines. These systems typically use AI-powered driver-facing cameras to monitor prolonged eye closure, yawning, head nodding, and other signs of fatigue before issuing real-time warnings. Detroit Assurance 5.0, for example, integrates a driver-facing camera with Bendix Safety Direct to improve driver monitoring. At the federal level, the Federal Motor Carrier Safety Administration is evaluating whether fatigue monitoring systems should eventually become mandatory for interstate trucking. According to research from the ADA Foundation, drowsy driving contributes to an estimated 6,000 fatal crashes each year in the United States, highlighting why fatigue remains one of the industry's most persistent safety challenges. Tesla has already introduced driver drowsiness warning in its passenger vehicles. Since 2023, the system has used the cabin-facing camera to detect behaviors such as yawning and blinking patterns, issuing warnings when it determines that the driver may be fatigued. The feature operates at speeds above 40 miles per hour when autopilot is disengaged. However, Tesla has not confirmed whether the Semi includes the same cabin-facing camera or identical fatigue detection capability. That uncertainty has become especially significant following the Nevada accident, where preliminary investigators believe the driver may have fallen asleep before the collision. At the same time, fatigue monitoring systems are not foolproof, as they can sometimes be bypassed or fail to identify every instance of driver fatigue. Ultimately, the investigation into Tesla Semi's first fatal crash is likely to focus not only on the driver's condition, but also on how the truck's active safety systems responded in the critical moments before impact. Until those findings are released, the incident should be viewed as an ongoing investigation rather than definitive evidence of either the strengths or weaknesses of Tesla's safety technology. Tesla isn't simply building more semi-trucks, it's reinventing how heavy-duty trucks are engineered, manufactured, and made safer. With its dedicated high-volume production line in Nevada now operational and designed for an eventual capacity of up to 50,000 Tesla semi-trucks per year, Tesla is preparing to accelerate deliveries while continuously refining the vehicle through real-world fleet data and over-the-air software updates. Industry analysts expect between 5,000 and 15,000 semi-deliveries during the initial production ramp, but Tesla's long-term ambition extends far beyond volume alone. Every truck leaving the factory benefits from stronger crash structures, improved battery protection, smarter AI safety systems, and manufacturing refinements aimed at reducing defects before they ever reach customers. Rather than chasing production numbers at the expense of quality, Tesla is using scale to make every new generation of the Semi safer than the last. Elon Musk's strategy is clear. The ultimate measure of success isn't just how many trucks Tesla can build, but how many lives those engineering improvements can help protect on highways around the world. What do you think about Tesla's strategy to make the Semi safer through continuous production and engineering upgrades? Share your thoughts in the comments below. And don't forget to like, subscribe, and turn on notifications so you never miss our latest videos, where we bring you the most exciting, in-depth, and up-to-date news, analysis, and breakthroughs from the world of Tesla electric vehicles.